Okay, so we're going to look at another example of using our definitions for the trig functions. Remember, those definitions are based on a right triangle. And so let's look at an example of how this is going to work. All right, so for this right triangle, I have not labeled the sides yet, so I'm going to go ahead and let's assume that they tell us that the hypotenuse is 4 and that this bottom side is 2. All right, our right triangle will be here, or our right angle will be there. And let's say that they put the angle theta up at the top this time. Okay, so this is what the problem looks like. And then the problem is going to ask us to find the values of the 6 trigonometric functions. Okay, so remember that we need all 3 sides of the triangle in order to do that. And so we have 2 sides. And so I'm going to go ahead and set up my Pythagorean theorem so that I can solve for the missing side. Remember that the side C is always the side that is opposite the right angle. So C has to be 4. The 2 can either be the A or the B. It really doesn't matter. I'm going to go ahead and put it in for the A. All right, so let's simplify. 2 squared, 2 times 2 is 4. 4 squared, 4 times 4 is 16. And then we're going to solve for B, so we'll subtract 4 from both sides. So I now have B squared is equal to 12. And in order to go from B squared to just B, we're going to take the square root of both sides. Okay, so at this point, you need to simplify the square root of 12. So you can either do that by using your calculator, all right, if your calculator has that feature. If it doesn't, then what you need to do is you need to come off to the side somewhere and you need to think about a way that you can multiply 2 numbers together to get 12. And ideally, you would like one of those numbers to be something that you could take the square root of. For example, I could say that 12 could be 6 times 2. But the problem with that is that I cannot take the square root of 6 and I cannot take the square root of 2. So that does not really help me. I can also write 12 as 3 times 4. Now this is better because while I can't take the square root of 3, I can take the square root of 4. So what I'm going to do now is just kind of showing you each step. I'm going to break the square root up. It's still multiplied. I'm just going to take the square root of them separately. I can't do anything with the square root of 3, so I'm just going to leave that. But the square root of 4 is 2. And then usually you'll see the numbers, like the 2, written on the outside of the square root. Okay, so the square root of 12 is 2 on the square root of 3. That's going to be my B value. That's going to be my missing side. Now, when we start dealing with the square roots, sometimes my calculations get a little bit trickier. Maybe a little bit more algebra coming into play. Okay, so for our 6 trig functions, remember that we have our SOHCAHTOA, which is going to help us remember the definitions. All right, and then we're going to go to our triangle and we're going to label. So remember that the across from the right angle is always your hypotenuse. Across from the angle that you're working with, that's going to be your opposite side. And then the other side, the side that's next to the angle that you're working with, that will be your adjacent side. All right, so let's see what we've got. So sine Sine is opposite over hypotenuse. So O is 2, hypotenuse is 4, and I can reduce that to 1/2. So sine is going to be 1/2. All right, let's look at the cosine. Cosine is going to be A over H. So A is 2 on the square root of 3, and H is 4. And again, I can reduce the 2 over 4. The 2 over 4 becomes 1/2. So first it looks like this, reducing the fraction to 1/2. And then we don't normally write that 1 in the front of the top part, so I'm just going to write it 3 over the square root of 2. All right, and then the third one is going to be the tangent. And our definition for tangent is opposite over adjacent. So the opposite is going to be 2, and the adjacent is going to be 2 on the square root of 3. Now, if you remember, we are not allowed to have a square root in the bottom of a fraction, so we're going to have to simplify that out. The first thing I'm going to do is go ahead and cancel these 2's, get that out of the way. All right, now we need to get rid of the square root in the bottom of the fraction. So if you remember that the way that you do that is you rationalize the denominator, which means that you take that square root of 3 and you multiply top and bottom by that square root of 3. So 1 times the square root of 3 stays the square root of 3. The square root of 3 times the square root of 3, that's like the square root of 3 squared. And remember that if you have that, the square and the square root sort of cancel each other out, and you're just left with a 3. Okay, so that is the first 3. And like I said, the algebra can get a little bit tricky there. And this is the kind of thing that if you have questions on the algebra, you need to be sure that you're asking those questions. All right, let's do the other 3. So remember, they are reciprocals. So for the cosecant, we're going to take the reciprocal of 1/2. So we'll flip that over. That's going to be 2 over 1, which is just going to be 2. For secant, we'll look at the cosine. So we're going to take the reciprocal of square root of 3 over 2. So we flip that over, 2 over the square root of 3. Now we do have to rationalize that. So we're going to again multiply top and bottom by square root of 3. So we have 2 on the square root of 3. And then on the bottom, square root of 3 times square root of 3 again is just equal to 3. All right, and our last one, cotangent. All right, we need to do a reciprocal here. Now, there's a little trick I'm going to show you that will make life a little bit easier. You can take the reciprocal at any point along the way. So yes, we could flip it over here. But the problem is if I turn it over right there, then I've got to rationalize it again because the square root of 3 is going to go in the bottom. Another option is to flip it right here before I rationalized it the first time. This is a much better place to work with. All right, so if I turn it over there, it becomes the square root of 3 over 1. And again, that's just going to be equal to the square root of 3. Okay, so that is a more complicated example, not necessarily because of the trig functions, but really because of the algebra and the simplifying that has to happen in order to get things in the right format.